it's Rebecca, and today in this video I'm going to be teaching you a little bit about the unit circle and what you can do with it. So first of all, what is the unit circle? Well, the unit circle is a circle with a radius of 1 that is centered at the origin, 0, 0. Now, there's a few important things to note about the unit circle before we can move on to any examples. First, this. All students take calculus. This is a handy acronym to help you remember what is positive and what coordinate. So in this first coordinate, or quadrant, my bad, in this first quadrant we know that all things, everything, is going to be positive here. This one we know that sine and cosecant are going to be positive. This one tan and cotangent, and this one cosine and secant. Another thing that's important to note is that the unit circle can be measured in both degrees and radians, like what I have written here. That's going to be a little bit more important in our example. The last thing is this, cosine theta, sine theta. This is what you use to write any point on the unit circle as a coordinate. Again, that'll be important in our example. So let's move on to our example. So here we are going to evaluate the unit circle. In our example, we have sine 5 pi over 6. Now this is in radians, that's important. So how are we going to solve for this? Well, first what we can do is we can find what 5 pi over 6 is in degrees. We know that 5 pi over 6 is equivalent to 150 degrees. So with this remaining 30 degrees, we're going to take this and turn it into a 30, 60, 90 right triangle so that we can solve for our sine. So because we know that this line here is equivalent to the radius of the unit circle, we know that this has to equal 1. And because we know that this equals 1, we know that this has to equal 1/2. So now let's take the sine for this 30 degrees. So we have our opposite, 1/2, over our hypotenuse, 1. So we know that sine of 5 pi over 6 is 1/2. Now, relating this back to our cosine theta, sine theta, we know that because we have sine here, we have just solved for our y-coordinate. So in our next example, we're going to see what else we can do with the unit circle. This scale comes directly from IXL MY6, in which we solve trig ratios using the unit circle. So in this problem, we're given this number set, 36 over 85 and 77 over 85. And what we're trying to find here is we're trying to find the tan theta of this number set. Well, how do we do that? Well, one thing that I mentioned earlier is that any set of numbers on the unit circle is equivalent to cosine theta, sine theta, and that applies to this number set here. So now that we know that, we can apply these values to these numbers. So we know that cosine is adjacent over hypotenuse, and we know that sine is opposite over hypotenuse. So we apply those numbers to tan theta, which is opposite over adjacent, and we have our opposite and our adjacent. So our final answer is 77 over 36. So now we're going to look at what we can do with the unit circle when we're trying to determine angles. So here we have this, determine the angle, 0 is less than or equal to theta is less than or equal to 360 for the following. So here we have cosine theta is equal to negative square root 2 over 2. So when we're looking at this, where do we start with this? Where do we get our reference angle? Well, we know that this is adjacent over hypotenuse. So if we take that, we can turn this into a 45, 45, 90 degree right triangle. So now that we have that right triangle, we can take this reference angle of 45 and apply it to our unit circle. Now, because we know that our cosine here is negative, we know that it has to be in either the second or third quadrant, because cosine is negative in these quadrants. So we're going to draw two reference angles of 45 degrees. But we know that our actual angles can't be 45 degrees because 45 degrees is in the first quadrant. So how are we going to solve for that? Well, we know that these two angles combined here, this quadrant and this quadrant, is 180 degrees. So we're going to take that and subtract the reference angle to get 135 degrees as our angle for theta 1. For theta 2, though, we are going to take this angle of the first and second quadrant and add it to our reference angle of 45 degrees. So for theta 2, we get 225 degrees. Those are the two possible angles that we could get for cosine theta equals negative square root 2 over 2.